Application of rational equations. So these are word problems, which I know everyone loves, but I'm gonna just go ahead. I printed off the problem from um, Agile Mind, but so it says a plane flies 450 miles with the wind and 300 miles against the wind in the same length of time. If the speed of the wind is 29 miles per hour, can you set up an equation and find the speed of the plane while in the air? So I always like to write the important information. So the info from this problem is they went 450 miles with the wind. What that means is the wind is kind of pushing it along since it's going with the wind. And then 300 miles against the wind. So when I fly from Durango to Albuquerque, I believe, and I might have this backwards, one way is always quicker than the other because usually the wind blows you one way. And I can't remember which way it is. I think the return trip from Dallas always goes quicker, but I could be wrong. I can't remember which way it is. And then, or maybe I'm just ready to get home. That could be it too. And then it says if the speed of the wind is 29 miles per hour, so 29 mile per hour wind. Can you set up an equation and find the speed of the plane? So the first thing, I'm going to draw a picture, and don't judge my plane. It's not going to look very good. So we have our little plane, and with the wind, so the wind is pushing it along, it's going to go 450 miles. Now, on its return trip or whatever, it's going to only go 300 miles because the wind is pushing against it. This is our wind. Okay, so they go the same distance. It goes from here to here, or here to here, and here to here. It goes the same distance. This one just goes 450 miles. This one goes 300. So remember when we're setting up rational, we always put the total divided by, let me open my notes and show you. So we always take the total and divide by x. So this was diluting solutions last week. So you always take the total amount and then divide it by like how much is being added to the original. So x is going to represent our speed because that's what we're looking for. So x equals speed. So then you're going to put x plus or minus something. So then let's go ahead and set up our two equations. So we know the total distance that it travels, or it went 450 miles, and then this one went 300 miles. Now, the speed of the plane, so it's x. Now this one's going with the wind, so it's adding 29 miles per hour. This one's going against, so it's resisting or going against the wind, so you have to subtract. So you're going to add 29 miles and then x minus 29. Because the speed that the plane is going, you need to subtract 29 miles. This one you need to add 29 because it's going that much faster. You also know that this one is going more, so you would have to add for that one. This one is going less, so it would have to be subtracted. You can't have the plus and minus switched. So then you're going to just solve just like you've been doing on the assignments. So there's no adding first, so I just need to simply cross multiply. So it'd be 450 times x minus 29 equals 300 x plus 29. Then distribute. So it'd be 450x and then 450 times negative 29. 450 times negative 29 is negative 13,050. Remember, bring down your equal sign. Distribute 300x. Distribute 300 times 29 is 8700. Okay, this is not quadratic, and you know it's not quadratic because none of these variables are squared. So what you need to do is you need to solve for x, so get x by itself. So we have a term with a variable there and a term with a variable there. They're on opposite sides, so I need to do the opposite to one of them. So I personally like to move the smaller one so I don't end up with a negative variable. So then 450 minus 300, that would be 150x minus 13050 equals 8700. Okay, now we're still trying to get the variable by itself. So what's the opposite or the inverse operation of subtracting 13,000? It would be to add 13,000 and add 13,050. So it would be 150x equals, and then so that I don't make a mistake, because we know I'm good at making mistakes, I'm going to add those two. So 8,700 plus 13,050 is 21,750. Okay, then I'm going to finish solving. So it's 150x. Remember, that's 150 times x, so the opposite of multiply is divide. Oops, this pink pen does not want to work very good. And divide. So I'm going to take that last answer and divide by 150. It's 145. So the plane speed is 145. It just went faster this direction because the wind was pushing it an extra 29 miles per hour. This one, it went slower because it was getting pushed against, there was a resistance against it, where it was getting pushed back 29 miles per hour. So this is the speed of the plane. So 145 miles per hour is the speed of the plane. Okay, so that's our first example. Now let's go ahead and do another one where they talk about a trip on a car and a trip in on a train. So Daryl works for a car dealership in San Jose, California. A customer is interested, in a particular color of a car that is not available in San Jose, but is available in a dealership in Los Angeles. Daryl's job is to pick up the car from Los Angeles and deliver it to the customer in San Jose. He takes the train from San Jose to Los Angeles, a distance of 350 miles, and drives the car for the return trip. The driving distance is also about 350 miles. He averages 25 miles per hour faster for the driving portion of the trip compared to the train portion. Daryl has only 16 hours for the round trip. What is the minimum average speed he must drive in the car? So again, I'm going to write out all of the important information. So info, the train's distance is 350. The car's distance is 350. The car went 25 miles per hour faster. The total trip has to be less, oh, sorry, not less, has to be 16 hours. So if we do exactly 16 hours, then it will tell us the lowest speed that he can take. He can go faster and he'd get there quicker, or he'd get done quicker, but he can't go any slower. And X is going to represent the speed of the train. Okay, so we know that when we're talking about like a distance traveled, sorry, there's the bell. When we're talking about the distance traveled, we know that his trip on the train plus his trip in the car have to equal 16. So however long it takes on the train plus however long it takes on the car has to equal 16. So the way we're going to do this is we're going to do, again, take the total, so 350 for the train, it travels a total of 350, and divide it by the speed of the train. So 350 divided by x is going to, so the distance they traveled divided by the speed is going to tell you how many hours. Because remember, speed is always miles per hour. So it tells you how many miles you can travel in an hour. Plus, we need to do the car. So the car is 350. So it traveled a distance of 350 divided by, now the speed of the car. We can't write x, we can't just write it as y. We need to reference the speed of the train. So it says that the car is 25 miles per hour faster than the train. So if you know the speed of the train, you would need to add 25 because it's 25 miles per hour faster, and then still equals our 16. Okay, so that is our equation. Now let's see. We're going to go ahead and solve it. So 350 over x plus 350 over x plus 25 equals 16. So we need to, now notice there's an addition sign, so you have to multiply across the bottom for a common denominator, then you have to multiply both across. So across the bottom is x times x plus 25, multiply diagonal or across, 350 times x would be 350x, plus, because there's an addition sign, if that was a subtraction sign you'd put minus, so 350x plus 25 still equals 16. Let me zoom in just a little bit, I'm writing kind of small. Okay, now we need to distribute. So that would be 350x, and then 350 times 25, which, again, I'm going to do it in my calculator so I don't make a mistake, is 8,750. And then multiply or distribute across the bottom. So x times x would be x squared. X times 25 would be plus 25x. So we have 350x plus 350x. So 350 plus 350 is 700. So our new equation is 700x plus 8750 over x squared plus 25x equals 16. Okay. Now we need to just cross multiply. So since there's an equal sign in between, you don't multiply across the bottom, you just multiply both crosses. So 700x plus 8750 times 1, so 700x plus 8750 equals 16 times x squared plus 25x. Distribute 16x squared plus 16 times 25 is 400, so that'd be 400x equals 700x plus 8750. So, since there is a squared, we know that we have to get everything equal to 0. It doesn't matter if you move this stuff over here or if you move this over here. I'm going to go ahead again. You know, I told you guys I don't like having negative x's. So something's going to end up being negative, but I don't like this being negative. So I'm going to subtract 700x and subtract 700x. That's going to cancel. And subtract 8750 and subtract 8750. Oops, I ran out of room. So then it would be 0 equals 16x squared stays the same. 400 minus 700, it's just the same as 700 minus 400 except for the answer's negative, but I'll still type it in. So 400 minus 700 is negative 300x, and then minus 8750. Okay, it's quadratic. You can either do the quadratic formula or you can type it in your calculator. I'm going to type it in my calculator. 16x squared minus 300x minus 8750. Hit graph. See this thing up here that's spinning? That means that it was still loading. So nothing popped up. It didn't give me an error, so I know it graphed it just somewhere. So I'm going to zoom out. So hit the zoom button, which is right here, and then go down to 3, which is out, and hit enter. See if it graphs it, that one. Oh, yep, there it goes. So it graphed both sides, so I need to now find the zeros. So second trace, go to 0. This number, notice, oh, it went too far. It was negative. So this is the hard thing about these ones. If you notice, that's a positive. When I hit it over once, it moves to negative. So positive, negative. So I need it to be on the positive side because that means it's up here at like 443. So that's the left side. Remember, we're doing left bound. And notice it popped up that arrow, which you want. It needs to be to that side of it. Then I need to hit the right arrow. Now it's negative, so it's down here. Hit enter, and hit enter again. So the first 0 is when x equals negative 15.82. And then let's find this one over here. So second trace, 0. I need to move this. Notice it's still going lower, 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 lower. It's starting to come back up. Okay, there, I can see that one. That one's to the left of it. Remember, left is this way, right is this way. So enter. Now it's at 474, so it's above. And enter. So x equals 34.57. Now, can it be going 2 speeds at the same time? No. Remember, x represents the speed of the train. So can the train be going a negative speed? No. You can never go a negative speed. Cannot go negative speed. So that one's out. Now this is the train. Let's look at the original problem and see what it asked us to look for. So it says, has only 16 hours. What's the minimum average speed he must drive in the car? So the question is asking about for the car, not for the train. So if we know the train, what did we say happens for the car compared to the train? Well, it goes 25 miles per hour faster. So if this is the train, to find the car, I need to add 25. So 34.57 plus 25. So the car has to go 59.57. That's the lowest speed it can go to make it in 16 hours. Anything slower than that, and it's going to take longer. Anything faster, like if they went 60, they would go a little bit more than 16 miles, or they would do it in a little bit less than 16 hours.